All right, recording's rolling. It's Friday, January 9th. Today's mostly going to be an Aleks day. You guys remember this assignment's been open for a few days, 7-1, 7-2, 7-3. Okay. And I have the due date for next Friday, so you guys got a whole other week to do this. Just this week, next week, it's a little bit different. Okay? But there's also, don't forget about your 70% pie goal, which is due 2 months from now. And then we got this tied together event going on today. So for context here, during the first short period. Okay. Hey guys, lesson 7-3, I'll do more on Monday. But here, I'll give you guys a little sneak preview to one of the topics they were talking about was compounding continuously. Okay. So I want to show you guys kind of what that looks like. So if this question shows up on Aleks, then, well, I guess you could handle it today if you want to. Okay. So the formula that you guys have seen over the past few days is the amount of money, say you could have an account is equal to the principal that you put in. So P could stand for principal. Okay? And then times, well, okay, if it's accumulating interest, 1 plus the interest rate to the power, so, and then 1 plus R is all raised to the power of time. Right? If you're compounding multiple times, like monthly or daily or something, right? You divide by n is the number of times that you compound. So if t is the number of years and you compound monthly, then what would n be? How about 12, right? Because they break this into like 12 months a year. Right? Okay, but if you're compounding continuously, then the formula actually looks a little bit different. T e to the RT. So more on that in a minute. And I'll do a numerical example with you guys. So let's say you have $1,000 in bank. You go up to the bank, you put in $1,000, and there's a 5% interest rate, and let's say it's accumulating interest for 20 years. You come back 20 years later. Right? How much money do you have? Well, it really depends on how it's being compounded. If it's compounded annually versus monthly versus daily, and let's say like every single nanosecond, I'll call it continuously. Okay? And now these will be fairly close to each other, but they will be a little bit different. So let's try it out. So I'll say the amount that you end up with after 20 years is equal to take the principal of $1,000 multiply by 1 plus the interest rate. And guys, the interest rate of 5%, what is that as a decimal?
0.05.
0.05. Okay, now if I do 1 plus that, I get 1.05. Right? Now, if it was just 1 year, would this just very simply expand by 5%? You have $1,050, boom, done. Right? But at the end of 2 years, 3 years, 4 years, now that money is accumulating and it's also gaining interest. So now you keep multiplying by 1.05 over and over and over again. And you do that 20 times for 20 years. That's why this is exponential. Right, let's say what we get in the calculator. $1,000 times 1.05, and then you do that 20 times. Okay? So that looks like $2,653 and maybe 30 cents. Okay. Now, what if you had the same scenario except you were compounding every month? So what that would look like is you take your $1,000 principal and multiply by 1 plus, and now 0.05 itself gets divided by what? Guys, what am I going to divide by right here? Every month. How many months in a year?
12.
12. 12. And then to the power of 12 months in a year for 20 years. Okay? Like that. Okay. Notice I didn't divide 1.05 by 12. Only the 0.05 bit. Is that? Okay. So up in the calculator, so 1,000 times, and then in parentheses 1 plus 0.05 on 12, close parentheses to the power of, and then open parentheses 12 by 20. Okay. So if you put this in the calculator all in one go, make sure you've correctly grouped together what needs to be grouped together. Make sure you get an answer that looks reasonable at the end. How many of you guys think the answer is going to be pretty close to $2,653, but a little bit different?
Yep.
Yeah. And it should be a little bit less or a little bit more. A little bit more. Okay, let's see. It is. It's $2,712.64. Okay. So yeah, it went up a little bit. Okay. Now, what if you compound every single day? And you do that for 20 years. So we're going to take our $1,000 principal times, and then 1 plus. Guys, what goes in this fraction right here? What divided by what?
Which one?
We're compounding daily, every single day. Yeah, so 0.05 divided by 365. You can do that. Okay. And then 365 days in a year for 20 years. Okay, we did. Okay. So in calculator, what I can do is I can scroll up, scroll over, and where the 12 months used to be, I can just replace that with 365. I have to insert a 5 there. Okay, and then same thing with this power. So I got 365. And do you guys think that this will be even a little bit more than $2712? See if it is. Okay. It is. It's $2,718.10. Okay. Okay. You guys good so far? Right. All right. So that's just review from last few days. Okay. Here's the one that's new that well, we're probably gonna go over more on Monday. Okay. Which is, what if you compound continuously? It's just like a continuous thing that goes on. Okay. And that equation actually takes a different form. You guys see this PE to the RT. Okay. So now the amount after 20 years is going to be the principal, which is same $1,000 times. Now E is a special character in math. Did I tell you guys this before? Guys, what is E equal to approximately?
2.6.
Close, close.
Oh.
Okay. Guys, it's actually stored on your calculator. Guys, everybody do this. Everybody has a small calculator. Hit second. Where's that? Hit second. And then you guys see this key says Ln, stands for natural log. We'll do that in a few weeks. Okay. But right above it says e to the x. So hit that. Do you guys see e to the power or something? Yeah? Okay. Okay. And then type 1. We're going to just do e to the power 1. Okay. Now, this is an irrational number.
2.7.
So, yeah, so it's non-repeating, kind of like pies. It's non-repeating. Right. So it's approximately 2.718. And this has some interesting mathematical properties, including the use that we're about to use it right here for a continuous compound. Okay. And we're going to do e to the power of, let's see, r times t. Well, the interest rate was 0.05 as a decimal. That's what 5% is. Okay. And we're going to multiply that over 20 years. Right, that's all in the power. Right, so in the calculator, go $1,000, and then second e to the power of, okay, and then 0.05 times 20, then close parenthesis. Okay. Guys, take a guess. What do you think the answer is going to be?
Smaller.
Huh. Well, here we got a pattern going. If you compounded annually, it was like $2,600 some dollars. Okay. Compound monthly, that's more often. It's a little more. It's 2,700. Compound every single day. Okay, now it's even a little more than that. Or 2,718. Ooh, now it's even more. Okay. So if you compound every single nanosecond, what do you think this is going to be?
A lot more.
Maybe a tiny bit more. Okay. I bet it's going to be a tiny bit more than that. Let's see. Okay. Yeah, look at that. It's 2718.28. Okay. So a little bit more than compounding every day. Okay. Is that? All right. So go ahead. You guys got the rest of the class. You can work on Aleks. Again, either this assignment or this assignment would be good to work on. If you have any questions, let me know. I can walk over and help you out.